This conference is brought to you by CallStack, a total software engineering consultancy.
Hello, everyone. Are you ready for a ghost story? It all started back in 2021 when TF1, the first media channel in France, decided they wanted to rebuild from scratch their news application. They wanted, a small team that could iterate quickly on the product. So obviously, they went for cross-platform, they went for React Native. Excellent choice, right? And I started to work for them in July 2021 with my previous company, BAM. Today, the app looks roughly like this. You have a feed of actualities on the home. It's all in French, sorry. You can click on the article, then you have the video player. And it's actually one important part of the app. Because as the first television channel in France, obviously TF1 is an important protagonist on the tech stage in France. They already had their own native player developed internally with their own dedicated team on iOS and Android. But we were the first time they ever went for React Native. So we had to develop the bridge ourselves to integrate the player. And it went well. The bridge is in production now. It's used daily by millions of users. We just had sometimes a few bugs on it. And the one I'm going to show you today is maybe one of the most memorable ones. It's back in February 2023, I decided for performance reasons that I no longer wanted to stack players, like pausing them when the screen was in the background. Instead, I just decided we should remove them completely, replacing them by a placeholder to have the minimal amount of players in the app active at the same time. And as soon as we started doing that, the removed player in the background, they started to play again. We could steal the sound in the background. It was easier to pause them to make them shut up than to destroy them and remove them from the React tree. It's like Emmanuel Macron forever talking in your ears, telling you how it's a good idea to not respect the election results. Yeah, terrible. How traumatizing is it? So this is the ghost player. And this is the story I'm going to tell you today. But maybe a few more words about me. As Mo said, I'm now working in a small startup in Paris to make EV charging easy for everyone. It's called Déjà Blue. I'll be happy to discuss that with you later. But I also love to dig under the hood of stuff in React Native. And today, the topic we're going to cover is the native lifecycle, native component lifecycle in React Native. Because we all know about the React lifecycle. A component mounts, it updates when it re-renders and receives new props, and months after being removed from the tree. But here, it's not what's happening. The player is unmounted, and still it's somewhere in the app because we can hear it. So let's go into this. We are first going to cover native lifecycle in the old architecture because it's where we add the bug. And obviously, I will explain how we solved it. But we are in 2024, you know? So second part will be about component lifecycle on the native side in the new architecture, and what are the differences. Okay, so how do you debug an invisible ghost player? There's a tool that you can use on Xcode that maybe not so many of you knows about. It's the memory graph. You simply open it by clicking on this button at the bottom of the screen, and it shows you a map of every single object in your application and the relationship between them. You have like the bold lines like this for the strong references, where the component cannot be garbage collected as soon as it has a strong reference to it. You also have light lines for weak references, where the object can be destroyed in memory, even if it has still some weak references around it. You can filter here at the bottom left to search for the component you want to observe. Here, the ghost player view for my example app. Yeah, that we have here in the center. But what we can see is we also have a ghost player view manager in the app. And what I can say is these view managers, even if you remove all of your native player, it still remains here in the memory. So maybe he's the one responsible for the sound we can still hear. How can we know that? We can look at another source of truth, the code. Oh yeah, somehow this manager relates to the bridge, so it plays something important here. Basically, when we look into the code, the view manager has 3 responsibilities. The first one of them is to register the native component for the React core system, saying, hey, here, there's something that you can call, there's a native component that you can use. This is this function extend module. Second responsibility is to provide a method on how to build the native component. And third responsibility is to declare the props the native component has and how it should adapt when the props change on the native side. This is all Objective-C on iOS, but you can define the code in the Swift file if you don't want to write Objective-C for the props management. Note also that we call this RCT view manager here. It's what gives us access to every default props of the view, like the style props, width and height. You do not have to redeclare it. You simply use this one, call this, and your component will have the style property on the JavaScript side. On Android, it's almost the same, except that the responsibility to declare the native component for the core system is given to another file called the package. But then the view manager has almost the same content. You have the method to instantiate the view, the declaration of the props, and we implement the simple view manager interface that gives us access to the default props. Let's have just a quick recap for later references. Every single component that you use in React Native follows the same standards. There's the view manager for basically every scroll view, safe area view, even the web view or third-party library you use. And if you code one of them one day, you will have to follow this standard. You can also note that the view does not do many things. It mainly obeys to the view manager above it, which is like the puppet master above the view. And now we know that we can finally connect the dots and build the lifecycle on the native side. So at app start, the React Native core system loops over manager and packager, gets all the view managers together, and they are here, ready to be used. This is like they are present in the memory. Even if no component is mounted, they are here to answer the call. We can recognize, yeah, safer, and all goes play a view manager, but every other component is here. At mounting time, let's say the user arrives on an article, the ghost player is rendered for the first time on the JavaScript. It's added to the React tree that is then sent through the bridge to the native, to what is called the UI manager. It's like the managers of the managers. It coordinates everything in the application. So, and he knows about them because they're registered at app start. And it's like, OK, I see there's a new player in tree. Can you bring me one of those guys? I know you know how to build one. View manager says, yes, I know the method. Let's do it. And the view is then inserted in the tree at the correct place by the UI manager. And it's exactly what we see on the memory graph on Xcode. We have the ghost player view here, and we can climb up and up and up from view to view to view to view until we reach the root view of the native tree. And there's a strong memory link between all of that. OK, what about the updates? The updates, like user have finished watching the video on the article, automatically a new video is loaded on the JavaScript side in the player. So the new props is sent. The UI manager received the new tree and contacts the view manager saying, hey, you know your guy that you brought me, it has to change. You have to make it adapt. Something is new. OK, I know exactly what method I have to use. And the props gets updated. Note that there is only one view manager for every view of the same kind in the app. You just have a system of tags to differentiate them that the UI manager gives, so it can apply the correct change of props to the correct component native. And it's very React, you know. Components in React are pure. For the same set of props in input, we have the same results in the output. So you can always apply the same methods. You can use the same view manager because it will always be the same rules. But I think it's cool it's on the native too. Now let's go to the last part of the lifecycle, the death. User navigates to another page of the app. Player is now in the background. We remove it, replacing it by the view on the JavaScript side. And yeah, it's removed from the tree. The UI manager just do the same. It cuts the link in the tree between the player view and the view above it. And because it has no strong reference to it anymore in the memory, it's basically garbage collected at the next step. But it's not what was happening to us. And when we looked into the memory graph in our case and the ghost player case, we saw that someone else was referencing our player. And this is why we could still hear its sound. We had something called a player controller above it. And we were completely outside. It's another parent, completely outside of the React Native flow. We don't know where it comes from, who invited this guy. It's messing things up. We don't understand. And the responsible for all of this, yeah, it's us, unfortunately. At the very beginning of the bridge story, someone else in my team added these lines of code in this layout subuse function. It roughly looks like the ones on the React Native video bridge, so there are probably some copy-pasting at some point. The first time we render the component on the native side, we basically create this player controller and attach it to our player. And somehow, above the player controller is a screen. So this is the story of the ghost player. And it's not an uncommon pattern at all. Actually, when I asked a very good friend of mine, ChatGPT, on how to build like a simple Swift player on iOS, he immediately answered, well, you have to build this player and this player controller. So using the AV player, and I know the TF1 player that we use, that we bridge, is also based on AV player. So there's no way to not have this controller. We simply, because it's not fitting with the React Native lifecycle, we have to work around. And this time, it's an iOS developer of the player team that actually gave me the solution on how to do that. Exactly as you have a cleanup in your useEffect function that allows you to execute some function before the component gets unmounted, you also have a dayinit callback on the native side that gets called just before the component unmounts. It's dialog in Objective-C. And guess what we did in the dayinit? Yes, destroying the player controller for good. So now Macron can just shut up forever. Yeah. Ooh, the ghost player was. Except in a very specific case on iOS 15 after I upgraded React Native screen in November. Well, I managed to work around and patching React Native screen, but the issue is still in progress. But when discussing the topic with the React Native screen maintainers, and I know they're somewhere in the room, one of them asked me, hey, what about Fabric? Fabric is a renderer in the new architecture. They asked, do you have the same problem with this dayinit function not called anymore? Yeah, great question. Let's try. I haven't migrated the TF1 app yet, and then I left my company, so it's up to them to do it. But I did. Sorry, guys. But I did a small proof of concept on my side, creating a React Native library with the new architecture. And I'm sorry to announce that in the new architecture, the ghost player is back. When we look at the memory graph after removing the component from the screen, in the new architecture, what we see, it's still present in the memory of the phone. And it somehow relates with weak references to something called the registry. So it's like, OK, there's some stuff different here. We need to know more. So what happens to the protagonist of our story? Let's look back again to our chart. In the new architecture, manager still declares the native components to the system. Obviously, the view still displays what it has to display. Now the method to instantiate the view is moved in the view and not in the view manager anymore. And as for the props declaration, it's now made in the codegen files. You probably have heard about codegen, unless you're living under a rock or something. It's part of the new architecture. It runs at build time during the pod install phase, more precisely, and it reads the TypeScript files to generate C++ files, but also native files that you can import to have the definition of your props. It gives you cross-language type checking, and this is really powerful because in the old architecture, when you manipulate a props, like for example, is playing Boolean for the player as compulsory and somehow forgets to declare it on the TypeScript side, the app would simply crash. But now at build time, we have this check from the TypeScript to the native, and I think it's really cool. Yes, and that was for the props declaration, but obviously the code for the native view to adapt when the props changes still live on the native side. And it's now for iOS a single function that received all the props that have changed at a single timestamp, instead of having one function, one callback for every props. But that's the only difference. OK. What happens for our lifecycle now? The beginning of the story is the same. As you know, JavaScript does not change on the new architecture. It's transparent for the end user, the end developer. You do not have to adapt what you have written on the JavaScript, which also is really cool. It goes through GSI in C++, and I won't detail this part because my talk is already too long, and obviously because I don't understand it either. And then it contacts the mounting manager. It's like the new UI manager and the new arch. And this one contacts the view registry. And this one, this guy, is connected to a recycle pool. And when the mounting manager says, OK, bring me a player, it first looks into the pool if there is a player view available on the native side that is not used currently and that we can just reuse. This is really important, and this is what I'm going to talk about in this second part. It's view recycling by default on iOS in the new architecture. If there is no player view available, it simply builds a new one by calling a view factory that calls the init_with_frame function we mentioned earlier in the chat. Apply the updateSprop function to initialize them, and then the view is inserted in the tree, just as before. But if it finds once, it directly goes to the update props part. It's like a re-render on the native side, reusing the component, exactly what FlatList does on the JavaScript side. And we do not call the init_with_frame function, so we economize that. But for the tree, it's the same. Like, we have the view here, we have the root view, and all the intermediary steps just as before. So the native tree at the end is also the same. When we update, I will go quite quickly on this one. New props is received, sent to the mounting manager that directly calls the view and say, OK, update props. As for the death, always my favorite part, spooky. Removed from tree, new tree communicated. And the view registry added to the pool, so the player view is not destroyed. It's simply removed from the native tree and put it inside the pool for later usage. This is exactly what we saw on the memory graph. Like, we have these weak references between the player and the registry. But on the user perspective, what would it mean on the TF1 Info app? It means user watches a video on article 1. We have player JavaScript number 1, player native number 1, closes the article, maybe plays a little Sudoku on the menu, I don't know, does everything. Opens a second article later. It's a new JavaScript player, but the native component behind is the same. Literally, it's the same that is reused, it's the same memory address. So in our case, because we have this player controller above it that we could not destroy because the player view was still part of the game, remember that? It means that we would have the sound of the player going on and on and on and on between the two actions of the users. And once again, we don't want to hear about French politics all the way. We want to live our life. So there's two solutions about that. The first, exactly as we had the deinit callback, we now have a prepare for recycle callback, where you can execute all the cleanup you need. But I also found a pull request on React Native from 2024. Yeah, this is, for example, the prepare for recycle callback for text input. Like, lots of cleanup done. This guy, I won't pronounce his name, sorry, made a pull request to make this view recycling process optional on iOS. And what is really interesting is it's a misconfiguration of components. For example, for the one connected to view controllers, it's exactly the same use case as us. Our player has a player controller, and it's messing things up with the view recycling on iOS. So we simply add a Boolean that you can declare in the view, and say, the component will never be recycled at the end. Every component of this kind will not be. And he immediately used his pair on React Native to update that on React Native screen and made it optional. And on the same pull request, he also cleaned everything he had put it before on the prepare to recycle. So as you can see, recycling a React Native screen was not easy. Yes, and we have still 2 questions to answer between finalizing this talk. First one is, why have they done that? It can be hard. You know, there's edge cases, there is ghost player that can occur. And the answer is, yeah, it's very cool. Thank you. This is the initial pull request that introduced view recycling in iOS. But it's not just very cool. Obviously, it's for performance reason. As we have seen, we do not enter the init with frame function. We just update the props when we reuse the same view, and it's more performant. And it's actually a very common pattern on iOS. Like the UI table view from UIKit, the UI collection view, by default implements view recycling. Here we have like a more powerful view recycling because it's cross components in the application. Like this is a screenshot of the recycle pool and everything you have like, yes, every component in React Native are recycled and they're all together in the pool. And if the pool gets too big and you have memory problem, your app is fast, but it's too big, there's this function, oops, sorry. There's this function, oh, sorry. It should appear there, but it's not appearing. The pool is just flushed. Like, we empty it as soon as the consumption of memory is too big. And this was the second question we have to answer. Yes. Oh, I'm sorry. What have I done? Okay, this is the function I was talking earlier. I'm sorry about that. Yes, to empty it. Yeah. What about Android? Like we kind of forgot about Android during the presentation, and obviously React Native and new architecture are also for Android. Even if I never had any ghost player with the platform, but I just want to do a quick check. Like for the table on Android, is it the same? View is the same. Manager is exactly the same. Create view instance, it's still in the manager on Android. You have to add this attract module in the package. And from the props, we are implementing the interface that CodeGen provides to us. So when you declare how to react to props change, you had to add the @override, basically, because now CodeGen file at the root of everything. What about view recycling on Android? Do they have it? And when we look at the code, it seems that there is. Remember that we implement the simple view manager, so we also extend the root function of it. And the default create view instance in the new architecture on Android first look at the recyclable view stack, and if there is none inside, we create a new one. So it's like exactly the same mechanism. We first try to reuse, and if we can't because it's empty, we create a new one. But when I tried to make it work, recyclable views, it was always null. I was like, well, I unmounted and remounted tons of components in my app, so the pool should be at some point filled with stuff. It wasn't, because view recycling in Android is still feature flagged, so it's not activated. You have to explicitly pass this flag to true to have it working, and I had it in the end. Question A, why is it different from iOS? Part of the answer is maybe like it's more recent. Remember the pull request for iOS recycling was made 6 years ago. On Android, it was only made 2 years ago by this guy. part of the answer is also that this guy left. Like a couple of weeks after merging the view recycling for Android, he left for OpenAI. And he's supposed to be user number 2 or 3 of ChatGPT, so it's almost a legend. But no, obviously React Native is a teamwork. There's a lot of people in Meta working on it, also on the community. So it's not because just one guy left that this has not been implemented. Actually, they are still experiencing with it. Nicola said to me, measuring the performance gain it brought to us. They already have implemented it for Litho. It's an Android framework kind of developed by Meta, and it's kind of the cousin of React Native because they also use Yoga. But as we have seen, and it's the whole point of the Ghost player story in the new architecture, view recycling is hard. You can have bugs. You have to take care of this. And this is the prepare to recycle callback on Android for a simple view. So as you can see, there's a lot of cleanup to do before putting actually the view in the pool. So, and believe it or not, the purpose of the core team is not to introduce bugs for the developer community, but rather to provide a stable, performant, cool framework to use for every one of us. So thanks to them, and it's the end of the talk. It was rather a deep dive in React Native. You do not need to know all of that to have your views and text working, but I think it's really cool to understand how it works behind the curtains. And yeah, thanks for listening for the Ghost player story.